Hello everyone, welcome to my channel. Today let us discuss about how to find the ABCD parameters for a given two-port network. So to find these ABCD parameters or the transmission parameters, first we need to write the parameter equations. The parameter equations are V1 and I1 are the dependent variables, can be given by AB2 minus BI2. CB2 minus DI2. So let us name these equations as 1 and 2. Now, to find A and C, here A is nothing but V1 by V2, C is I1 by V2, with the condition I2 equal to 0 is true. I2 is 0. If you substitute I2 equal to 0 in this two-port network, so this will be open circuited. So this node voltage becomes V2. Now let us find the relations so that we can find this ratio V1 by V2. So to find V1 by V2, let us apply current division at this node so that we can express V2 in terms of I1. So let us consider this is current IB and this is IA after the current division. So what is IB? IB here is I1 into entering current I1 into opposite resistance is this one. 2 by 2 plus 2 plus 4. The total resistance 2 plus 2 plus 4. So this is 2I1 by 8. That is I1 by 4. So if you express the relation V2 is 4IB. So 4 into IB is I1 by 4. So this is I1. Now let us find the input resistance at these terminals, and that is given by V1 by I1, which is equal to, so this is open circuited. So these 2 ohms and 4 ohm are in series. So total is 6 ohms. This 6 ohms resistor and 2 ohms are in parallel. So 2 into 6 divided by 2 plus 6. So 12 divided by 8, that is 3 by 2. This 3 by 2 ohms and 1 ohm are in series. So the resulting combination is 1 plus 3 by 2. So this is 5 by 2. It's equal to 2.5 ohms is the input resistance or the equivalent resistance at the input terminals. So V1 by I1. So what is A is simply V1 by V2 with condition I2 equal to 0. What is V1 in terms of I1 is 2.5 I1. What is V2 in terms of I1? It's equal to I1. So A is 2.5 and C is I1 by V2. We have seen the relation between I1 and V2 is V2 equal to I1. So this ratio becomes I1 by V2, which is equal to 1. It's equal to 1 mho. The units are mho. Units for A is V1 by V2. So this is 2.5 only. So this is voltage transfer ratio. A is voltage transfer ratio and C is transfer admittance. Now to find B and D, let us substitute B is, let us see, B is minus V1 by I2 and D is minus I1 by I2 with condition V2 equal to 0, with condition V2 equal to 0. So if you substitute V2 equal to 0 in the given circuit, we'll get the output port is short circuited. So this 4 ohms and short circuit path are in parallel. So we can neglect this 4 ohm resistor. It's 4 ohm. This is I1. This is V1. This is I2. Now see this one. This short circuit path and 4 ohm are in parallel. So we can neglect this 4 ohm resistor, or we can remove this 4 ohm resistor. So if you remove this 4 ohm resistor, we'll get the equivalent circuit. The circuit will be look like this. So if you see this circuit, that will be let us see this circuit. This is 1 ohm resistor. This is 2 ohm resistor. There will be a 2 ohm resistor, and this 4 ohms is parallel to this short circuit path. We can neglect. So now this, if you observe this circuit, you can see that the input resistance is V1 by I1, which is equal to this 2 ohms and 2 ohms are in parallel. So that combination is 1 ohm. 1 ohm and this combination are in series. So 1 plus 1, this is 2 ohms. Input resistance is 2 ohms. So that from this we can write V1 equal to 2I1. Now let us find the relation between I1 and I2. So apply current division, we'll get this is consider Iy, this is Ix. So Iy is nothing but applying current division, entering current is I1, opposite resistance is 2, and total resistance is 4 ohms. So this is I1 by 2. Here Iy equal to minus I2. Why? Because these two are in opposite direction. Magnitude wise, these two are same. So now what is the relation between I1 and I2 is I2 is minus I1 by 2. I2 is minus I1 by 2. Now if you see B, what is B? Minus V1 by I2. V1 I can write it as 2I1. V1 I can write it as 2I1. Divide by I2 can be written as minus I1 by 2. I2 can be written as minus I1 by 2. So this minus and minus gets cancelled. I1 gets cancelled. We'll get B is 4. The units are ohms only. This is transfer impedance. Coming to D is minus I1 by I2. So we have the relation between I1 and I2. So minus I1 by I2 can be written as 2. There are no units. This is transfer current ratio. Okay. Now the ABCD parameters can be written as in the matrix form as A is, we have determined A is 2.5, C is 1, B is 4, and D is 2. These are the ABCD parameters. So only the C is measured in mho and B is measured in ohms. A and DR have no units. These are transfer, voltage ratio, and current ratio. Okay, for the same circuit, let us find the H parameters. We can find the H parameters for this given two-port network. consider this two-port network, the same two-port network. This current I2, this is voltage V2, this 4 ohm resistor, 2 ohms, 2 ohms, 1 ohm resistor. This is V1, this I1. Now, to find the H parameters, first write down the H parameter equations. H parameter equations are V1, I2 are dependent variables. This is H11, I1 plus H12, I2, sorry, V2, H12, V2, H21, I1 plus H22, V2. To find the H parameters, H11 and H21, we need to make V2 as 0. To find H11 and H21, put V2 is 0. Put V2 is 0. So if V2 is 0, you have seen the condition 4 ohms parallel with short circuit path. We have seen the relation between these two is V1 is 2I1 and I2 is minus I1 by 2. So what is H11? H11 is V1 by I1. So it is equal to 2 ohms. H21 is I2 by I1. I2 by I1. So this is minus 1 by 2. This minus 1 by 2 or minus 0.5. There are no units as this is current ratio. So to find H12 and H22. What is H12 is H12 is V1 by V2 and H22 is I2 by V2. H12 is V1 by V2, H22 is I2 by V2. So what is the condition? Here is I1 is 0, I1 is 0. If you substitute I1 equal to 0 in this circuit, this 1 ohm resistor, if you open circuit these terminals, what happens is there is no current flow through this 1 ohm resistor. So there is no voltage drop across 1 ohm resistor. So this node voltage becomes V1. Okay, let us redraw the circuit as this is 2 ohms. This is also 2 ohm resistor. This is 4 ohm resistor. This is I2. This is V2. Now this node voltage is V2. This resistor is 2 ohms, 2 ohms and 4 ohms. Now see this one. So here I2, if you find the input output impedance or the resistance at output terminals, these 2 ohms and 2 ohms are in series and this combination is parallel with 4 ohm resistor. So 2 plus 2 parallel with 4 ohm resistor. So 4 parallel with 4, that is 4 by 2, that is 2 ohms. So R equivalent at the output terminals is 2 ohms. R equivalent at output terminals is 2 ohms. So that is V2 by I2 is 2, which implies I2 by V2 is 1 by 2, that is 0.5. Similarly, H12, to find the relation, this is entering current is I2. So apply current division principle. This is Ix and Iy. So what is Ix? What is Ix in terms of I2 is entering current at that node is I2 multiplied by opposite resistance is 4 ohms and divided by 4 plus 2 plus 2. So this is I2 into 4 by 8. So this is I2 by 2. It's equal. So what is V2 in terms of Vx? V2 is 2 into Ix. So this is 2 into Ix is I2 by 2, I2 by 2. So this is equal to I2. This is equal to I2. What is this node voltage? This is V1. This is V1. V1 is equal to I2. So H12 is V1 in terms of V1 in terms of I2 is simply I2 divided by V2 in terms of I2 is V2 is 2I2. V2 is 2I2. So this is 1 by 2. It's equal to 0.5. Now, what are the H parameters? Are H11, we got 2 ohms. H11, we got 2 ohms. H12 is 0.5. H21 is minus 0.5. H22 again 0.5. So these are the H parameters for the given two-port network. Okay, thank you. Thank you for watching.